This relationship is a little bit more complicated, and if we take a look at the data here, it gives you the day of the year. So 2 would represent January 2nd, 8 would represent January 8th, 56 would be like probably maybe February, someday in February. And we've been given these days of the year, and we're given the number of hours of daylight. Okay, so obviously this would be winter, so we're going to have very little daylight. In the middle of summer, we're going to have quite a bit of daylight. Okay, and as we go back to winter, we get less daylight. So we're going to plot this data. So this is not necessarily a simple relationship. It's not going to be a straight line. If you know anything about the hours of light in a year, we know it's going to kind of go up and down. So I'm going to make my scale along the x-axis here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I'm maybe going to make my scale maybe like 1.5 or something like that. So each day, each one of these is going to represent 15 days. So I'm going to go maybe 30 here. I'm going to do this in black. And all I'm doing is making my scale so that I can fit my 355 days. Now this is, you can choose a different scale, and maybe your scale is going to be better than mine, but this is kind of my scale here. And it's not great, but it's probably good enough. And that's really what I'm looking for. In science, we're probably going to want to have a much better scale than this, but for now, I just want a good enough scale. Okay, so I just want to fit my 360 days into here. So I have 355, I know it's 365 days in a year. So the hours of daylight, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since the maximum is 16 or 17, I'm just going to I don't always have to go down to 0. I'm just going to make this 17 and go up by 1. So 16, 15 here, 13, and I'm pretty sure I can get down to, I just got to make sure I can fit the 7 point whatever. Okay, so there's 9, and there's my 7 hours of daylight. Okay, so I'm going to be able to fit all this into my graph. So day number 2 is going to be 7.75, so somewhere around here. Oops. So I'm going to have 7.75. It doesn't have to be super accurate, as long as it's somewhere around. 8 is going to be 7.94, somewhere around here. Okay. At day 56, it's going to be 10.42, so it's 10 there, so 10.42, maybe about there. Okay, and then at day 83, so 70, 80, 75, 83, somewhere around here. It's going to be 12.46, so somewhere around there, 12.46. Day 150 is going to be 16.45, so maybe about there. Day 200 somewhere right about here, 16.31, so maybe somewhere in there. And 355 is going to be back down to 7, almost just a little under 8. Okay, so somewhere around here. And when we look at the pattern of this, we should expect kind of it going up like this, kind of evening out, and coming back down. And this is going to form something called a sinusoidal curve. Okay, and it's this kind of, this type of curve is kind of the sinusoidal or sine curve. And this gives us the hours of daylight, and this is a repeating pattern because once we get back down to here, we know it's going to go back up for the next year and keep on continuing. Okay, so this is a repeating pattern. So describe the relationship, well, it's kind of hard, but if you know this shape, we can call it a sine curve. Okay, otherwise you can say it just kind of goes up and down. And maybe I'm just going to say it goes up and down. Okay, and the quantities being related, well, the dependent variable is the hours, of daylight. Okay, so that's my output. That's my y variable. Okay, and the independent is day of the year. Is day of year. Okay, and that's along my x. That's my input. And that's my x variable. Okay, and I get this graph that kind of looks like this.